All right, so this is on milk storage. The highest temperature at which milk can be stored to remain fresh for X days can be modeled as f of x equals negative 9.9 ln of x plus 60.5 degrees Fahrenheit. Now, what is the highest temperature at which milk can be stored to remain fresh for at least 5 days? And how quickly is the required temperature changing at that point? All right, well, what we need to do is f of 5, okay? So that should give us the highest temperature. And so that's going to be negative 9.9 times ln of 5 plus 60.5 degrees Fahrenheit. And so if we plug that into our calculator, we get negative 9.9 ln of 5 plus 60.5. And that tells us a temperature of 44.56. I'm going to say 7 degrees Fahrenheit. So we don't really probably need that many decimal places, but I'm just going to kind of have it because I've seen below what's the average rate of change. And so I need to have f of 5 to get that average rate of change. Okay. Well, I won't actually have to do it for that one, but I'm going to have to use it. Okay, so what's the next question? How quickly is the required temperature changing at this point? Well, that means I have to find f prime of x, and then after that, plug in a 5. Okay, well, if I look at this, that's a number, so that's a constant, so that's going to go to 0. That's a number here, so I'm just taking the ln of x. Well, the ln of x is 1 over x, so that's really just going to be negative 9.9 over x for my derivative, and that's all it is. And that's going to be degrees Fahrenheit, and that's going to be per x days, so it's going to be per day. And then I want f prime of 5, which is negative 9.9 divided by 5, and that's equal to negative 9.9 divided by 5, negative 1.98 degrees Fahrenheit per day. Okay, so every day at that point in time, it's negative 1.98 degrees Fahrenheit per day, which is the highest temperature it could be reached. So that's where we're at that point. So that was all in A. Now B, what is the average rate of change in required in the storage temperature between 3 and 7 days? Okay, well, that just means we need to take and find what is f of the highest, 7, minus f of the lowest, which is 3, all over 7 minus 3. Okay, so we have to remember back to last chapter to remember that formula. So if we do that, let's plug that in, and we have, so we have a 7 there. So that gives us, roughly 41.235. And again, I'm just going to write the estimated down here, and then I can actually put the full thing here in a second. And so then it was 3. So that's going to be 49.623. That works. Actually, it's going to be a 4 because that rounds up. And 235, that doesn't round up, so we're good there. And then over 7 minus 3. Okay. Now, if we take and do the whole thing, we'll have the following, and I'll put in all the decimal places in my calculator. 235. All right, so that, if I plug it all in, gives me negative 2.097 degrees Fahrenheit per day. Okay. Now, as the number of days increases, does the rate of change of temperature increase or decrease? Okay. Well, if we're looking at the derivative function here, it's going to be always negative for the output, no matter what day we put in, because negative 9.9 divided by whatever day it is going to be a negative number. So, as a basically as we go further and further, that's going to get closer and closer to 0, because if we're at like 20 days, that's basically 10 divided by 20, which is a half. And then, we keep going closer and closer, and we're going to get closer to that 0 value. So, we're going to say always negative based on the derivative, which is negative 9.9 over x. And so for all x, and yeah, and then we could also say the rate of change of the temperature. Now, how is that going? More negative, and it's going to get less and less and less negative. So we're going to get closer to having a rate of change is actually increasing. So, but I'm just going to leave it as that. And the other one is more complex. You have to draw a picture to kind of get to that. And I can see it, but I don't want to draw all this extra stuff. But so it's going to be doing that. So but basically our rate of change of temperature is going to have increasing. Okay. All right. So let's stop there.